Okay, so let's talk about AI because we are at this really critical moment. New research is showing that it's standing at a fork in the road. And one path, well, it leads to a kind of genius we can barely imagine. But the other path, it leads to a total collapse into beautifully spoken but completely meaningless nonsense. So the big question is, how do we make sure we pick the right path?
At the very heart of this whole dilemma is a concept called recursive AI. Now, that's just a fancy way of saying it's what happens when AI starts learning from, well, other AI. Just imagine an AI writes an article, and then another AI comes along and uses that same article for its training data. And that creates even more data for other AIs to learn from. See the problem? It's a massive AI echo chamber, a feedback loop that can easily spiral out of control. And this feedback loop, it creates this huge paradox. I mean, on the one hand, you could see this as the latter AI needs to climb to just these unbelievable new heights of intelligence. But on the other hand, the research warns about something called model collapse. That's when an AI basically just starts making things up, and semantic drift, where the actual meaning of words starts to decay and fall apart.
Now, to help us make sense of these two very different futures, the researchers came up with a framework, and it has a very academic-sounding name, the Recursive Impact Trim Continuum. But look, don't worry about the name. All it really is a way to visualize a spectrum, a way to see which direction an AI is heading, toward actual genius or toward fluent nonsense.
So this spectrum shows us the two possible outcomes. Over on one side, in the red, you get semantic collapse. This is where the AI sounds perfect. Its grammar is flawless. But it's really just a fluent parrot, you know? It's just repeating patterns without any real understanding of what it's saying. But on the other side, in the green, you have intelligent amplification. This is the goal. It's where each learning cycle makes the AI genuinely smarter, building on real, solid knowledge. So what is it that decides which path an AI takes? How does it choose? Well, it all boils down to just a few key variables that basically control whether the system can hang on to meaning or if it just lets it all slip away. First up, there's a variable called alpha. You can think of this as the system's defect amplifier. It's kind of like that awful screeching feedback you get when a microphone is too close to a speaker. A tiny, tiny little error gets picked up, then it gets repeated and amplified over and over until it's just this loud, incoherent noise. For an AI, that's exactly how a tiny mistake can spiral into a gigantic fabrication. So fighting against all that feedback is beta. And if alpha is the amplifier, beta is the system's internal shock absorber. It's the AI's own ability to catch and correct itself, to resist those errors that alpha's trying to blow up. Beta is the force that's constantly trying to pull the system back from that spiral into nonsense. Next, we have omega, and honestly, this might be the most important one of all. It measures something called semantic integrity. And put simply, it answers the question, how much real meaning is actually surviving each time the AI learns something new? You know, is the AI actually learning the concept of a cat? Or is it just learning that the letters C, A, T often show up next to the word meow? That difference is absolutely crucial. Then you've got pi, and pi is all about context. So an AI might know the dictionary definition of a word. That's omega. But pi is what measures whether it knows how to use that word in the right situation. It's really the difference between knowing what a joke is and knowing when to tell one. It's all about timing and appropriateness. But when you get right down to it, the ultimate stabilizing force, the one thing that can reliably prevent a total collapse, is what the paper calls pH, the probability of human participation. Think of it like a grounding wire on an electrical circuit. As long as there's a real human in the loop to correct, interpret, and anchor the AI to the real world, the system has a fighting chance to stay on track. And hey, this isn't just some theory cooked up in a lab. We have already seen both of these paths, total catastrophic collapse and incredible steady growth, play out with real AI systems, right out in the wild.
These examples really tell the whole story. Remember Microsoft's Tay chatbot from back in 2016? That was a classic case of collapse. It was designed to learn from totally unfiltered internet comments. So its error amplification, that alpha factor we talked about, just went completely haywire. It collapsed into gibberish in less than 24 hours. Now, on the flip side, you have DeepMind Sparrow, which was built with human oversight from the get-go. That's our pH grounding wire. And it led to stable, progressive improvement. And then you have ChatGPT, which is a fascinating case of a system in the middle, constantly using structured human feedback to pull itself back towards stability and coherence. This whole process can lead to a really dangerous phenomenon the researchers call performative collapse. What they found was that as these AI systems fed on their own data,
their factual accuracy absolutely plummeted. It dropped by 27%. But here's the truly scary part. Their confidence in their own wrong answers actually grew by 18%. So just think about that. The AI gets dumber, but it sounds more sure of itself than ever before.
The research even found a specific quantifiable tipping point. Remember omega, our measure of how much real meaning is being preserved? Well, if that number drops below 0.7, which means the system has lost just 30% of its connection to the original meaning, the collapse becomes irreversible. It is literally the point of no return.
So, what does this all mean for the future of AI? Well, it means we need a pretty radical shift in how we think about managing these systems. We have to stop just asking, is the AI accurate? And we need to start asking, is the AI actually making sense? Does it have semantic integrity? Is it preserving real-world meaning?
So the solution that's proposed is this new architecture made of 4 interlocking safety loops. First, you have a semantic loop to protect the core meaning of concepts. Then a pragmatic loop to make sure everything is contextually relevant. A third loop, the reflective loop, lets the AI actually correct itself. And finally, the most important one, the human loop, providing that essential final anchor to reality and common sense.
The paper's author, Erickson Katz, really puts it perfectly. Intelligence is a gift, but intelligibility is a responsibility. And that's such a powerful reminder, right? Just making AI smart is not enough. We have a responsibility to make sure it remains understandable and connected to the world that it's supposed to be helping.
Which leaves us all with one final and, I think, pretty critical question. This research proves that meaning inside an AI system doesn't just happen by itself. It has to be designed, it has to be carefully built and protected. So the question for all of us really is, as AI builds our future, who gets to be the architects of its meaning?